In this lesson, we're going to look at the way that sign numbers work when they're being multiplied and when they're being divided. I like to look at these patterns by observing a multiplication table. And we can use our multiplication facts, like we learned a long time ago, to see what happens with our multiplication of sign numbers. Now, your multiplication tables, as you originally memorized them, started off, and I'm going to use a multiplication table for 5 for my example. You start off multiplying by 0. So we would say 5 times 0 is 0. 5 times 1 is 5. 5 times 2 is 10. 5 times 3 is 15. 5 times 4 is 20, and so on. Not going to continue this on too long because we've made a point here already. We've already observed, if we're going to come over here and make note of our rules, we've observed that a positive number, when multiplied by another positive number, gives us a positive number for the result. This is something that we probably knew a long time ago before we really put much thought into the negatives. Now this pattern, of course, continues on down in this direction as far as you want to carry it. But what I want to look at is what happens when we go back up the table in the opposite direction. Note that since this is a 5's table, as we went back up, we will continue to have 5 in that column. Still a multiplication type setting, but if we look at what we're multiplying by, there's a pattern here. The pattern, going back up, goes 4, 3, 2, 1, 0. The next number would be a negative 1, followed by a negative 2, followed by a negative 3, etc. Now the other pattern that we're going to observe is the pattern over here with our products. The 20 became 15, which dropped to 10, which dropped to 5. So what we're seeing here is that it's going, each time it's dropping by 5, and then next time dropping by 5 again, and that is because it is a 5's table, but each time our answer is dropping by 5. So if we can't count down, 20 goes down to 15, which goes down to 10, which goes down to 5, which goes down to 0. Drop by 5 again, we'd be at negative 5. Drop by 5 again, we'd be at negative 10. Drop by 5 again, we'd be at negative 15. So what we've seen with this is that a positive, when multiplied by a negative, is giving us a negative result. Now, if we want to look at the other possibility, if we want to think about what would happen with a negative being multiplied by a positive, well, we just need to remember that multiplication is commutative, meaning the order in which you multiply does not matter. So we can just go ahead and generalize that this is going to give us a negative result as well. Now, what we haven't looked at is what's going to happen, or the one thing we haven't seen is what's going to happen when we multiply a negative times another negative. And we can take this table in a new direction to figure this out. I'm going to duplicate it since I'm going to run out of space. I'm going to duplicate some of it down here. We had, for example, 5 times negative 2 giving us negative 10. We had 5 times negative 3 giving us negative 15. What we can do is, instead of taking the negative 2 down to negative 3, which it would then go down to negative 4, I'm going to take the negative 3 and hold it where it is. And then I'm going to take the 5 and drop it to a 4. And again, hold the negative 3 where it is. Take the 4, drop it down to a 3. So the results we're going to see a negative 12 here. We're going to see a negative 9 there. This 3 would become a 2, down to 1, down to 0, to negative 1, and so on. Again, still a multiplication table, so we'll fill that in. And the negative 3, we said we were going to hold constant, not let it change. So let's see what happens to our products. as we go through and complete these multiplications, we see negative 12 drop to negative 9, which would then drop to negative 6, to negative 3, to 0. Now let's again observe a pattern. Negative 15 to negative 12 to negative 9 to negative 6 to negative 3. What's actually happening here, if you pay careful attention, these values are actually increasing by 3, because we've changed this to a threes table, to actually a negative 3 multiplication table now. And if we increase by 3 yet one more time, we get a positive 3 result. So we've just found that a negative times a negative is going to give us a positive result. So we can generalize to say that when we're multiplying, for multiplying one of each, that we get a negative result. When we multiply, though, two of a kind, we get a positive result. And we can actually take this generalization just a little bit further. We could say, for example, if we're multiplying 6 numbers, 1, 2, 3, 4, 5, and 6, that if we had maybe 1, 2, 3 of them being positive, while 1, 2, 3 of them were negative, what would in effect happen is that 2 of the negatives would cancel each other out. 1 negative would be left. The answer from this would be negative. If we were multiplying together, say, 10 values, and 6 of them were negative, well, multiplying 10 numbers together, with 6 of them being negative, then the negatives would actually cancel each other out, 1, 2 at a time, and in that case, again, we would have a positive answer. This all can be confirmed for us on our calculator. We can build, like we did earlier, a 5's multiplication table. We can scroll down through it, and we can see the values that we looked at. We can go up to the top of the table, to the 0, to the negative 1 entry, to the negative 2 entry, and so on. And again, this is a 5's table, so all you're seeing over here on this side are the actual products. But we can do these calculations on the calculator as well. But you have to be aware that your calculator has a negative key and it has a subtraction key. They may look a lot alike, but they aren't interchangeable. If I want to do a multiplication, I can take, say, negative 5 times a negative 7, for example, and it will demonstrate that that is a positive result. I can multiply one of each. I can multiply a negative 3 times positive 2, and again we see the negative answer. So the calculator can easily verify these rules for us to show us that they are working exactly the way we think they should. And now we need to look at division. Now once multiplication is taken care of, division is really not that hard to deal with. If we simply remember that division can be defined, or is defined, often through the use of multiplication. As a matter of fact, about any multiplication problem that you choose to write can tell you 2 division facts. For example, 5 times 3, back to our multiplication table of 5s here, 5 times 3 is 15. That one multiplication problem tells us 2 things. It tells us, for example, 15 divided by 3 is 5. It can also be used to tell us that 15 divided by 5 is 3. So this one problem can become both of these division problems. So what we've already seen with this first example is that our first multiplication rule can be turned into our first division rule. Alright, and let's see if we can do something like that again. Let's take a 5 times a negative 3. We already know that gives us a negative 15. Well, this one too can be rewritten two ways. It can be written as negative 15 divided by negative 3. That gives us positive 5 as a result. So here's another rule for us that's been adapted to work with division, and that is a negative divided by a negative is also a positive. Alright, next rule to look at. Let's go to a larger eraser and come up here and see if we can come up with another rule. Okay, again back to a similar multiplication problem. Negative 5 times 3 is negative 15. Let's rearrange this one. Let's turn this into negative 15 divided by 3. Of course, our answer would be the negative 5. And we've just verified that when you divide one of each, you once again get a negative answer. So in essence, what we've just seen is that the multiplication rules and the division rules are absolutely identical. So you really just have one set of rules to remember, and you're completely taken care of on both of those operations. Now, one other thing that's worthy of mention here when it comes to the division is what happens with fractions. I want to take a look at and compare 3 different fractions. And here's what they look like. And what I'm wondering is, does it matter if the negative sign is on the top or on the bottom or simply off to the side? Are these fractions in fact the same, or are they actually different? And we can see what the calculator thinks about that. First of all, putting it on top, we get a negative 0.6. Put it on the bottom, and we once again negative 0.6. And for the last one, we'll simply put it on the outside as to apply it to the entire fraction, and once again negative 0.6. So what this tells us is that we can actually make a generalization here that whether the negative is on the top or whether it's on the bottom or simply off to the side, it's all the same thing. So this allows us, when we're dealing with problems and fractions are involved, to put our negative signs wherever we want. Top, bottom, off to the side, it's all going to be the same. Now, just as a matter of convenience, I always put my negative signs on top. I think it's easier to put in the calculator, and it's easier to work with when you're doing things, say, like arithmetic with your sign numbers. So remember, just to keep it simple, keep your negative sign on top, but if you encounter one on the bottom or off to the side, it all means the same thing.